Now we are going to discuss about the pH. What is meant by the pH of a solution? So pH of a solution is a negative logarithm of molar concentration of H positive ions in that solution. So pH is equal to minus logarithm of molar concentration of H positive ions in that solution. So pH of a solution 7 means that is a neutral solution. If the pH of a solution greater than 7 means that is an alkaline solution, and if the pH of a solution is less than 7 means that is an acidic solution. So the pH of a human blood is 7.4. That means it is slightly alkaline. Human blood is slightly alkaline in nature. So we just go through a simple problem. So there is a problem here. Calculate pH of 0.01 molar hydrochloric acid in its full ionized form. So according to our definition, pH is equal to minus logarithm of H positive ion. So here hydrochloric acid is fully ionized. That means the active mass, when hydrochloric acid ionized, we will get H positive plus Cl negative ion. So the concentration of H positive ion in that solution is 0.01 molar. Because a strong acid, there is a complete ionization will be taking place. So 0.01 means 1 divided by 100. That's equal to 10 raised to minus 2 molar. So the 10 raised to minus 2 is the concentration, the active mass of the concentration of H positive ions in that solution. So according to our equation, pH is equal to minus logarithm of H positive ion. So we can substitute the H positive is equal to minus 2. So minus logarithm of 10 to the power of minus 2. So when we rearrange this equation, we can write like this: minus, we take the power into here, so minus of minus 2, this minus 2 means 10 to the power of minus 2 into log 10. So minus of minus 2 log 10. We know log 10 is equal to 1, so minus of minus 2 is equal to 2. That means pH is equal to 2. That means the solution is acidic, strongly acidic. So we are going to discuss now what is meant by common ion effect. So I will take an example here. This is sodium acetate plus sodium chloride. You know, the sodium acetate is a weak electrolyte and the sodium chloride is a strong electrolyte. So what is meant by the weak electrolyte? Weak electrolyte means there is the degree of ionization of that electrolyte is very slow or very low. And the strong electrolytes, they can completely ionize into corresponding ions. So in the case of sodium acetate, the degree of ionization of sodium acetate can be reduced or suppressed by adding sodium chloride. And this phenomenon is known as a common ion effect. So what is meant by common ion effect? Common ion effect is if a strong electrolyte is added to a weak electrolyte having a common ion, the degree of ionization of the weak electrolyte will be reduced or suppressed by the presence of the strong electrolyte having a common ion. And that phenomenon is known as a common ion effect. So here, sodium acetate, the ionization of sodium acetate into acetate ion plus sodium ion will be very slow generally. But in this case, if we add sodium chloride, we know this is strong electrolyte, so can easily form Na positive and OH negative. Sorry, Na positive plus Cl negative ion. So you can also add sodium hydroxide. So in that case, Na positive plus OH negative. So this effect is known as a common ion effect. So next we are just to go through what is meant by buffer solution. What is meant by a buffer solution? Buffer solution is a mixture of two electrolytes or two solutions that can resist the small changes of pH by the addition of acids or bases into that solution. So buffer solution is a certain solutions we are using the sudden pH change of a solution by the addition of acids or bases. So buffer solution prevents the pH changes. So generally there are two types of buffer solutions. The one is known as a acidic buffer solution and other one is a basic buffer solution. So generally acidic buffer solution is formed from weak acid and its salt, and basic buffer solution formed weak base and its salt. For example, acetic acid plus sodium acetate. Here acetic acid is a weak acid and its salt sodium acetate. Because of it's a weak acid, it is known as a acidic buffer. And another one, ammonium hydroxide, is a weak base and its salts ammonium chloride. So here the base is very weak, so that type of buffer is called a basic buffer. Next we are going through what is meant by a solubility product. Solubility product of a saturated sparingly salt. For example, AB. Here is an equation. AB gives A positive plus B negative. So AB is in a solid state and that gives A positive a cation plus B negative anion in aqueous state. So after a particular time, there is an equilibrium exists between the solid state and liquid state. So there is an equilibrium exists between solid state and aqueous state. So here we are applying the concept of equilibrium constant. So here the equilibrium constant we had seen that earlier in a sense. What is equilibrium constant? Equilibrium constant K is equal to the product of, it's a ratio, the product of active mass of products divided by the active mass of reactants. So here the products are A positive and B negative. So K is equal to the product of active mass of products divided by the active mass of the reactants. So K is equal to active mass of A into active mass of B divided by active mass of AB. So when we rearrange this equation, that's AB comes here. So KAB is equal to A product of A plus and B minus. So we are applying a condition here at a particular temperature. What happens to the concentration of AB, that is at a particular temperature is considered to be a constant. So here there is equilibrium constant, there is another constant, so K into another constant, that gives a new constant is known as KSP. So here KSP means the solubility product of AB. Solubility product of AB. So KSP is equal to the product of active mass of products. So that's about the solubility product. So I hope you enjoyed these lessons. Thanks for watching. God bless.